Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called Pass Through the Mist by Chili. And here are the rules. Fog of War. The grid is partially covered in fog. Placing correct digits will clear fog, possibly revealing more clues. So this should not require guessing. You don't have to guess for this. It should all be logically you could all be logically deduced. Chaos construction. Each row, column, and region contains the digits 1 through 9 exactly once each. A region is an orthogonally connected collection of cells, and regions are to be determined. So, this is normal Sudoku rules with the rows and columns, but the regions can be any shape essentially. It could even be a 3 by 3 box, but it just has to contain 9 digits. That's all we know. So the shape could actually, and it has to be orthogonally connected. So for example, this is a valid region. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this region, if this were a region, you would have to have the digits 1 through 9 once each. And that's chaos construction. Arrows. The digit in a cell containing an arrow indicates the number of region borders in that direction. If there is more than one arrow, the number of borders is the same in each direction, not the total for all directions. The outer edges of the grid do not count as borders. Okay, so here's an example of an arrow, of a cell with an arrow in it. So what it's saying is, if say this were like a 2, that would mean that there are two borders that that separate regions on this essentially in this direction. In addition, since there's an arrow on the other side, there has to be two borders on this side. So from the arrow to the edge of the grid, you would see two region borders, but that does not include the border surrounding the grid. And it's not total. Remember, it's each direction. So if this is 2, that means there's 2 this way, and then there's 2 this way. Not 2 in total. Again, remember, the outer edges of the grid do not count as borders. So it's specifically separating out cells. Circles. And a digit in a circle equals the number of cells seen horizontally and vertically that are in the same region as the digit, including itself. Borders obstruct vision. So, for example, there's one circle here, right? Say we saw a border like, I don't know, something like that. That equals the number of cells seen horizontally that are in the same region as the digit, including itself. Borders obstruct vision. Okay, that's not. So in this case, this would see, including itself, 1, 2, 3, 4, 5. Because it orthogonally means that they share an edge. Oh, if it's horizontally and vertically. So yeah, it's the same thing as orthogonally. But that'd be 1, 2, 3, 4, 5. Borders obstruct vision. So this would be 5 in this shape. Now, if we were to have a different shape, for example, like something like this, then this square would not count as those seen. So this would be 1, 2, 3, and 4 because the border obstructs vision. So it'd be 1, 2, 3, 4. So this would be a 4 if this was the region. And remember, so this has arrows and it has a circle. So it has both different types of clues that are available. just to make sure that you know that. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so I'm going to be using that right now. So there's at most, actually there has to be, no, there's one or two. We don't know which. There's one or two cells. It can never be one, right? So if it's, yeah, this can never be one because circles can never be one, right? It has to contain, the regions are orthogonally connected, right? Oh, I forgot to say orthogonally is, I did say that in the second part, but orthogonally means that they share an edge. So if this is one, quote unquote, you would have to have a border here. It would basically be by itself because it's not possible. Therefore, this must be a 2. So this is 2, which means this is a border and this is a border because the border of the edge does not count. The outer edges of the grid do not count as borders. So this is a border, this is a border, which means this is a border and this is a border. So these are all borders. And it sees 2. So one of these has to be a border and then one of them is connected to the other one. Okay, this sees 1 and 1. This has to be 1 and 1. Because there's only one possibility. Because, again, the edge borders do not count. The outer edges of the grid do not count as borders. So this has to be 1. And we know the border has to be here and here that it sees. Now this could be 2 at most, but since this is 2, and the chaos construction says each row and column contains the digits 1 to 9 each once. So that one's still the same as normal Sudoku. This must be a 1. And we don't know which one it is. It could be either border here. So we don't know which one it is. Okay. And that's in this direction. This could see up to 3. So this is 1, 2, or 3. We don't know which. This could see 1, 2. So let's count. This would be 1, 2, 3, 4, 5, 6, 7. So it could be up to 7. This could be 1, 2, 3, 4, 5. Or 1, 2, oops. 1, 2, and 3 borders. So that's this 3 at most. So this is 1, 2, or 3. Okay, so this is a border. That's interesting. So we're going to color this. Ooh, we don't know. We don't know about this one either. This could be blocked off. Okay, this is 1, 2, or 3 because it's 3 that way and 5 this way. This could be up to 7. So this is 2, 3, 4, 5, 6, or 7. These two cells cannot seem the same amount, but it could have a border in between them. This is also, okay, so this cannot be 1. It could, so one of them's here. Okay. One thing we do know. Say this was the border, right? If this was the border, the number of squares this could see would be the exact same as this one. Because neither of them can see horizontally, but both can see the same vertically. But then they would be both the same numbers, which would contradict our chaos construction rules of every column having the digits 1 through 9 each. Therefore, this cannot be blocking. This cannot be the border. Therefore, we know this has to be the border. And this is whatever that is plus 1. So this can be up to 9. It could be 2, 3, 4, 5, 6, 7, 8, or 9. This has to be 1 through 8. This can't be 2, though, so this can't be 3. Because these see the same vertically. but horizontally this sees one more. In addition, this also has to be on the same in the same region as these four, because we have defined already that it can only go this way. Therefore, this has to have a difference horizontally than these other squares. So it must be at least 2. And we know there's 1 at least this way. So this cannot be a border across here. This cannot be a border across here. Therefore, we know this is the border. And this has to be what these are plus 2. Or what this one is plus 2. So if that's 1, this is 3. If this is 3, this is 4. If this is 4, this is 5. Wait, no, hold on. If this is 1, this is 3. If this is 3, this is 5. 4 means 6. 5 means 7. 6 means 8. And 7 means 9. So this can no longer be 8, and this can no longer be 9. So this sees 2. So this is 1. And therefore, there's only one border between here and here. Okay. This has to be 3 or 4. Right? It can't be 1 or 2 because of the chaos construction rules, which is normal Sudoku rules for rows and columns. But we have 1, 2. This could be 1 across this, and this could be 1. So this is 3 or 4. We see 1 here. We know there's 1 here. This has to be 2. Right? So none of these are. We know this is 1, and we know there's only one other one between the rest of this. So this is 2. In addition, okay, since this is 2, this cannot be 2. Right? Because if this is 2 and this were part of this region, sorry, this cannot be part of this region. And we know this part is part of this region. In addition, we have this, we have a border between these two. So this has to be a different region than this. Okay, so this is red. We're going to make this red. Red makes it confusing. We're going to make this purple. This all has to be the same region. This has to be a different region. So we're going to make that yellow. Okay, so this doesn't have to be a different region. But this has to be a different region from this. And therefore, okay, this does have to be a different region from that. Because we know that this is different. So this is also a different region than these two. So this actually, we know this is part of this purple region. So this has to have a border here because we know those are two separate regions. And then this cannot go down. So this has to be a separate region. It could be the blue. It could be some other one. So we're going to make that orange. But we just know that the border has to be there. Right? So now we have 1, 2, 3, and 4. So this sees at least 4. So this cannot be 1 or 3. This can't be 3 or 5. This can't be 2 or 4. This has a 2. Okay, so this could see at most 1, 2, 3, and 4. So it could be 1 through 4. This has to be the orange, essentially. Oh. Okay, this has to be yellow. Because this has to continue. This has to be blue. These are different. So this has to be blue. That has to be yellow. This has to be blue then. So this could go up. We don't know this part. This cannot be yellow. It could be orange though. Okay, so this sees at most 1, 2, 3, or 4. So this is 1 through 4 also. It can't be 1 though. This sees at most, so this can't be 1. This sees at most 1, 2, 3, and 4. So this is also 1 through 4. It's one same that way, right? So this is 1, 2, 3, 4. So then we have 5, 6, 7, 8, and 9 in the rest of the row. So this must see 5 at least. If this is part of pink, so say this was part of pink, we have 1, 2, 3, 4, 5, 6, 7. This would make 8. The problem is you only have at most 9 here, right? You only have one other cell you can see. So it would only see 3 vertically. So this cannot be 5. Therefore, this cannot be, this has to be a different color. Let's make this yellow also. This is a different yellow. We just would run out of essentially colors if that's the case. So this has to be different. So one of these is 1, one of these is 4. This could all be different. Okay, so we know there's at least one here. Oh, this is 1, 2, or 3. So this has to be at least 1, 2, or 3. It has to be at least one less. Because this sees... So that means this has to be 1 greater than this, and this one sees this one as a boundary. So this has to be a boundary. So this sees 1 less, this sees 1 less, and this sees 1 more, right? Because these digits cannot be the same, because you cannot have the same digit in the same column. So one has to be greater than the other, and this one sees this border and all the rest of the borders. So this is 1 or 2, this is 2 or 3. So there's 2 or 3 here too. This sees 3 or 4. We right now see 3. If this were 3, this is part of this one. So we have 1, 2, 3, 4, 5, 6, 7. Okay, this cannot be 1. This can't be 1, this can't be 1, this can't be 1. Okay, it cannot go this way. So we try, so it either has to go here or it has to go here. So it's 1, 2, 3, 4, 5, 6, 7. This would have to be 8 and 9. But the problem is this can't be 1. None of these could be 1. And then these two couldn't be 1. Therefore, it cannot go this way. It has to go this way. And then one of these is 1. So it could continue still with this one, technically. We don't know, though. So it has to at least go here. One of these is 1. We don't know which. It could be this one. It could be that one. It could continue on here. So this is at least 5. So this sees at least 5. So this can't be 4. This can't be 6. And this can't be 5. So this sees at least 5. It cannot see more than 5 because it's 1, 2, 3. So I cannot see more than 6. So this is 5 or 6. So this is 7 or 8. This is 6 or 7. So 6 and 7 are all already taken in the pink, right? If this is 5, this is 6, and this is 7. If this is 6, this is 7, this is 8. So there is no... So this can't be 2. We know there's... So this is 1. Okay, this can't be 1. None of these can be 1 here. So this is 3, 4, 5. No 6, 7, 8, or 9. And then the 1 has to be one of those two. This has to be different. So if it sees this, I guess the 5 could be like that. That is possible. So this still could be part of this whole. If this is 1, that would mean the border would have to be... it doesn't matter. It's either this one or this. It's either this border or that border. If it's 3 or 4, then this becomes 1. I don't think it could be 4, right? If it's 4, that means the 1 would have to be there. But the problem is that would have to be part of the purple. So then you would have 1, 2, 3 to 3 borders. So this can never be 4. Interesting. So if this is 3, this would have to be 4. I think one of these has to be 3, right? If this is 3, it's part of the purple, and this has to be 1. And then this would see all 3 of those. Yeah, so that either this is 3 or this is 3. If this is 3, this becomes 1, and this becomes 4, right? So if this contains this, that's 3. If it doesn't contain this, this has to be 4 then. Wait, don't necessarily know if that's 3. Hmm. Interesting. Okay. That doesn't help. Um, yeah, it could contain those. Oh, this is okay, so this cannot be 1, but it could it sees already 4. So this is 4, 5, 6, 7, 8. It cannot be 9 because there's nothing vertically. So it could just be seeing those 8. This sees 2, so that's whatever that is. 2, 3, 4. This is 1 or 2. This is if this is 2. Okay, so this already sees 1 here. So this sees 1 definitely. Um if this is purple. So say this goes purple. If that's purple, this would make 1, 2, 3 borders, but that can't be 3. Therefore, this cannot be purple. Therefore, this is something else. Therefore, this is a border, and now this is 4. So this can't be 4. This can't be 4 anymore. So this is the purple. And we know this is a border. This probably isn't. We don't know. So this is 1, again, 1, 3, 4, 5, no 6 or 7, 8 or 9. So one of these is 1. 4 is, we don't know. Okay. Okay, so yeah, these are borders. So this is a border, this is a border. This has to be a border. So this sees 4, right? Which is 1, 2, 3, and 4. That works. This is 2 or 3. This is 1 or 3. So, okay, this one specifically we know has to go that way. If this is 3, obviously this has to be 1. If this is not 1, this has to be 1. So if this is 3, this obviously has to be 1. If this is 3, that's 1, 2, and 3. That seems possible. If this is 3, this has to be, yeah. If this is 3, this has to be 1, which is fine. If this is 3, this is 2, this is 1, that's 2. Okay, that's fine. If this is 1, this is 2, this is 3. So this can never be 3. There's at least 2 here and maybe 3. There's at least 2 here, but we don't know which. Okay, here. This is 1. This sees only 1. Hmm. This has to be a different yellow. So, actually, we don't even know that, though. Let's make it... Yeah, let's just make this green. Just easier. Okay, so this is solved for... Oh, we know exactly what this is, then. This one sees 6. So this becomes 6, this is 7, and this is 8. So there cannot be an 8 anywhere. There cannot be a 6 or 7. Well, we already knew that. So one of these is 9. That can't be 2. Hmm. Interesting. Okay, what if this is 1? If this is 1, it cannot be part of this. So it can these are different regions. So if this is 1, we've already seen this, so this would all be green, right? So this would all be green if that's 1. This would have to be a different region. Um, this would be 1 at most. Orange has to go here. So then you would have to have, okay, so then that doesn't work, right? Orange has to go here. We already have a border there for 1. Therefore, orange would have to be the same as yellow, and that just doesn't work. Or orange would have to be the same as green, and that doesn't work. So this cannot be 1. This must be 2. So this is 2. This is 3. This is 3. This is 1. So there are no borders anywhere else. So this is not a border, and that's not a border for certain. Okay, so that's actually different. So we're going to make this blue. Because we know all 3 of those are in the same region. Because there's only 1 border there. And that's already satisfied. So this is 2. This is 2. So this one, interesting. If the orange goes here, the problem is you have 1, 2, 3 borders, right? Because the 2 cannot be with this 2. So this one would have to be a different region from there. Therefore, this orange specifically cannot go here, right? Say the orange went here. We know then this becomes a border. There has to be a border between this 2 and this region, but there can't be anymore because we have 2. So therefore, the orange cannot go here. The orange has to go up. So this has to go up. And it cannot go this way, and this one cannot go this way, right? If it does go that way, same problem, right? You have an orange here. You would have to have a yellow and an orange blocking here, but then this region could not be the same as this region. So the orange can never go right. So this has to be a different region for something. So therefore, the orange only can go left. So this can't be... so I guess we could just make this blue. Well, let's make it orange just for certain. This is orange, so it has to go up. It could go here. It could go here. We don't know which. This has 3, so this is 1. Oh, this is 3. So then this has to be a separate rate. This is a border, this is a border, and this is a border. So we know those are all borders. So this is a border, this is a border, and this is a border. Okay, so then this is a separate region as this. This cannot be orange. We don't know what it is. This could be the same one as this. In fact, actually, we know that. This has to be the border. Because this cannot be the same as this region, right? So then we also know this is a border. So we have 2 borders this way, so therefore these are the same. So the green is the same as the orange. So this is an orange, this is an orange. It must see 5 diagonally, so this has to be orange and orange at least. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this could only be 5 or 6. Therefore, this cannot connect with this, because then it would have to extend 3 more. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 size region, and that's not possible. So this has to be different. So this is not allowed. So this blue is actually a separate region than this orange. So this is 5, 6, 7, 8, 9. No 6 here because of this 6. This is 5, 6, 7, 8, 9. And then we have an extra one somewhere. This sees 3 borders. We don't know which. Yeah. This is 3. We have 2 here already. And there has to, so this cannot be yellow. This has to be something different from yellow. It could be part of this blue technically. No, it can't be. 5, 6, 7, 8, 9. Yeah, that just doesn't reach. So say we try to make it this way. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a 9 region, but then this becomes 1, 2, 3, 4, 5, 6, 7. And that's not big enough. So this has to be a different region than yellow and blue. So we're just going to make this another purple. And this is a different purple. And it won't ever touch this because this already has all the borders set. We have one more, so yeah. Between yellow and something else. It can't be blue. It has to be purple then. So either one of these is yellow, one of these is, both of these could be yellow, both of these could be purple, one of them could be 1 and 1. We just don't know. This is probably purple, but we don't know. This sees all 4, that's good. This sees, we don't know. 4 through 8. The 2 has to be here, so there has to be a 2 here. 2, 3, 4, 5, and 9. This is 3, 4, 5, 6, 7, 8, and 9. No, 6 because of this. This is 3, 4, 5, 6, 7, 8, and 9. No, 4 because of this 4. So this is 3, 5, 6, 7, 8, and 9. This can't be 3, though. This is also 3, 4, 5, 6, 7, 8, and 9. Okay, so all the 1s are accounted for. Okay, this is 1 or 2. So this sees 1 or 2. We don't know which. This 5 through 9. Technically, it could see all 9. This can't be. We don't know where the other one is. So one of these is blue, obviously. It could be both. We don't know. Oh, we need a 1. So I guess this could be 1. So this is 1, 2, 3, 4. So with 2 is here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is at most to here, which means we have one of the ones here. This is 2, 3, 4, 5, 6, 8, and 9. This can't be 3 because of this 3. This can't be 2 or 3 because of this 2 or 3. Everything else is fine. This is 3, 4, 5, 6, 7, 9. This can't be 3 because of that 3. We have 2, 3, 4, 5, 6, 7, 8, and 9. This can't be 2 or 3. We have, well, we don't know. I'm just gonna clear that. This is 1. Oh, this is all the same region. So okay. If this were yellow then, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this cannot be yellow, therefore this is purple. Therefore we know all 5 of these have to be the same because we've already got the border here. So either this is yellow or this is purple. This is separate and it cannot be orange. We're going to make this yellow. It's a different yellow than this one. So this is purple. If it's here, it still works, right? You can see 1, 2, So it's 1, 2, 3, 4, 5, 6, 7. You can add 2 and then 3, 4, 5. So that would work. Unlikely, but it's possible. How many squares are taken in by these? So we know, okay, so how many squares left are in this shape? This is 1, 2, 3, 4, 5, 6. Okay, so 1 plus 5, that's 6. Plus 8, that's 14. Plus 7, that's 21. Now, these two regions take up 18 of those, right? So again, this is 21. I guess we could have done 3 times 9 minus 6. Yeah, it's just 21. So this is 21, and these two regions, the yellow and the blue region, both take up 9. So that's 18. So 21 minus 9 is 18. There must be 3 other cells that are not part of those two regions, and it can only be part of purple. Therefore, we know exactly what this cannot contain any more because it has 3 already. Right? So again, this is made up of 21 cells. This set is of 21 cells. 18 of them are taken up by yellow and blue. 3 of them are left over, and they can only go to this purple. So therefore, we have 6 here, and then we have 3 more. So therefore, this cannot be... yeah. So therefore, this is a separate region than all of these. This then becomes, can only see 5 here, 6, 7, 8. So this cannot be 9. Okay, so this has all the regions. So then the 1 has to be one of these. We don't know which. One of these is purple, one of these is yellow. Okay. This becomes 1, 3, 4, 5, 7, 8, 9. So no 3 here because of that. This is 2, 4, 5, 6, 7, 8, 9. This is 1, 4, 5, 6, 7, 8, 9. Okay. So this needs a 1. It also needs an 8. So 1 and 8 are somewhere here. It could go down here. Okay, so this actually could go here. So this is, okay. This cannot, this has to be... Okay, can this ever go down here? No, because that blocks up blue. So this cannot be purple. It cannot be yellow either because that blocks up blue. Therefore, this has to be blue. Can this be purple? It can't be yellow because the same problem of it blocks off blue. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9 would be the most if it goes up. So this has to be blue. If it goes purple, that blocks off blue, and then you have 3 things that don't work. This actually could be blue or purple. This could be blue, purple, or yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be, this could be blue or purple also. So this could be yellow. Oh, this can't be yellow. If this is yellow, it's this way, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 if it goes up. But to get there, it has to be 1, 2, 3, 4, 5, 6, 7, 8. So this cannot be yellow. So we have, yeah, something like this. 1 is blue, or 1 is purple. Or, yeah, so all 3 of these could be, so 1, 2, 3, 4, 5, 6. If that's the case, yeah. Oh, 8. Well, no, that could be 1. So that could be the 1. We know, yeah, one of these two. It could be something like that. That's fine too. Okay. Hmm. What about this? Hmm. Guess this could be blue, maybe, and then this would be a different shape. Hmm. Okay, so yeah, this is different from that. Okay, what else do we need? This could still be 4 to 8. Oh, it can't be 8. If it's 8, then all of these would be yellow, but then blue would be cut off. So this is 4 to 7. I don't know if that helps very much. We needed 2. Oh, so it cannot go that way. So this, I mean, it could go here. So if it goes this, if it only goes this way, so this 1, 2, 3, 4, 5. So say it doesn't go this way, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess it could be 6, 7, 8, and 9 there. That's possible. That's, yeah, very possible. Oh, this is an arrow. I missed that. This is an arrow. So this has to be at least 4. So it's 1, 2, 3, 4, 5 at most. So this is 5 at most. But this cannot be. So this is 4 or 5. So this, then this is not. So this is 1, 2, 3, and 4. So this has to be a 4. Not 5. It has to be a 4. So no 4 here, no 4 here, no 4 here. That means each one of these is a border. So this is a border, this is a border, this is a border, this is a border. Which means this is blue. This cannot be blue. So this has to be yellow. And yeah, we showed that this has to be the yellow, and then this could be 2. Because there's no other place for 2 for this yellow shape. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And this has to be the 2. So this is already shape size 9. Therefore, the yellow is already taken care of. So this yellow, we can draw the borders. This is different from there. Okay. So one of these is 1. We don't, okay, so we don't know what these are. Oops. Color-wise, we don't know what these are. So this can't be 4. This can't be 1 anymore. There's no 1 here. One of these is 1. Oops. I did it again. Color-wise, we don't know what this is. What just happened? Oh, it's fog. I forgot. Okay, so this cannot be 1. This cannot be 4 either. So this can't be 4. Therefore, this is a 1-4 pair. Because 1 and 4 can no longer be in any of these. So this is 1 and 4. So one of these is 1, one of these is 4. We know the 4 is here. So whichever one of the is, yeah, that's fine. So the 4 cannot be here, right? If any of these were 4, okay, so this can't be 4 either because of the row and column Sudoku rules still apply. This is a combination of 1 and 4. We know this purple has a 4. Therefore, this 4 has to belong to the blue. Therefore, there cannot be a 4 in any cell that's a blue, but this could still be a 4. So that's still possible. This is still possible. Okay, now this sees 1. How many borders? 1, 2, 3, 4, 5, and 6. So this is 6. 6, not 5. So this can't be 6. This can't be 6. This can't be 6. There's no 6 here. These can't be 6. This sees 1, 2, 3, 4, 5, 6, 7. If it goes this way, that's only 7. Oh, in fact, actually, it has to go this way. We know this is a purple. This cannot see 7. So that would be 1, 2, 3, 4, 5, 6. If it goes this way, it would have to go here. Right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. But then this would see 7. So if it goes this way, these two are different. Oh, wait, could be that way. Okay, so it cannot be 9. This has to be 8. It can't be 7, and it already sees 6. So it has to be 8 or 9. But if it were 9, this wouldn't work, right? Because you have 6, and you would have to add 3 more, but then this would be a 10 cell shape. So this has to be 8. So this is 8. These can't be 8. These can't be 8. This can't be 8. That can't be 8. If it's here, this has to be an 8. So if it goes this way, this has to be an 8. So it can go either this way or that way. So then if it goes this way, this one has to be 8. So this is blue. So this has to be purple, which means this is purple, which means this has to be 1, and this has to be 4. So this has to be part of the blue, because there's no other place for 4. This can't be 4. None of these can be 4. Sorry. One of these has to be 4. So this has to be, let's just draw in the border. Therefore, this is purple. This cannot be 4 then. Therefore, this has to be 4, which means this can't be 4. So, and this can't be 4. So this has to be 2 and 4 with one of 3, 5, or 9. We don't know which. Okay, so this is 6. That's done. This has to have an 8, and this is the only place for it. So this is 8. This cannot be 8. This cannot be 8. This cannot be 8. Oh, so we see. So this is 6, and we see 5 here. So this is 5. So this can't be 5. This can't be 5. This can't be 5. These can't be 5. All because of Sudoku. Oh, yeah, this 6 also sees only 6. Right, so we kind of knew that anyway, either way. Let's see. Where does this go? So this can't be 5 here. This can't be 5. So this becomes a 3, 7, 8, 9 quad set. So this one has to be the 5, because there's no other place in row 3, or row 7, sorry. Row 3 from the bottom, but row 7 actually in actuality. So this is 5, which means this cannot be 5. So this can't be 5 either. This can't be 5. This is 2 or 9. We have 2, 3. This is 5. This can't be 6. This can't be 6. So this becomes a 3, 7, 9 triplet in row 8. So this has to be the 6. Which means none of these can be 6. Oh, wait, hold up. There's at least one border here. So the border at the furthest would be here. So this would be at most 7. So this cannot be 8. This would be at most 7. Okay, so where is the 8 then in row 5? It can't be here. It cannot be here. It cannot be these two. This has to be 8 then. So this is an 8. This can't be 8. This is 5. One of these is 7. Okay, so one of these is 1. Okay, so this becomes 2, 3, 4, 5, 6, 7, 9. No 3 here, obviously. This is 1, 3, 4, 5, 6, 7, 9. No 3 here. One of these has to be blue. We don't know where the orange is. The orange could be any of these four. Hmm. And it would have to be because it would have to be. Oh, this is 5. So since this is 5, this has to be 6. So this sees 6, then this would have to be 5 or 7. There's no 6 anymore here. This can't be 6. This can't be 6. This sees 1, 2, 3, 4, 5. And the only way possible to extend would be here. So this is orange. Therefore, this is blue. And we can draw the border here. So this can no longer be 3 or 5. So this is 7, 8, 9, 7, 8, 9, 7, 8, 9 in this column, in column 2. So that eliminates 7, 8, and 9 everywhere else in that column. So this is 3 and this is 5. So this cannot be 5 in this blue. The only 5 possible in column 1 is here. So this is a 5, which means this can't be 5. This can't be 5, and this can't be 5. And none of these can be 5. And this can't be 5. And these can't be 3, so we have a 7, 8, 9 triplet here, which is fine. Okay, so the orange region is all done. So this is all orange. The blue has to continue out. So that has to be blue. This sees at least 5, so it must see 9, because it cannot be 2, 3, or 4. So this has to be a 9. Which means it sees everything else. So this has to be blue. So this is all one thing. So then this is 3. Where am I? This is 3. This cannot be 3 or 9. This can't be 9. This can't be 9. This can't be 9. We know in this column it cannot contain a 2 or 4. So this has to be 1, 3. We already have a 5, 9, so this is 1, 3, 6, 7, 8 in the rest of it. 1, 3, 6, 1, 3, 6, 7, 6, 7, 8. So let's remove the ones we already know we can't have. So then this has to be a 2, 4 pair. Because, again, the 2 and 4 cannot be in this shape. And this 9 sees all the squares of the region. So then this is a 2, this is a 4. We have the shape, so we know this one goes this way. This sees all of these, so this is a 7. So there's no 7 here. This has to be 1, because we know that's 1, and that's it. So this has to be 1, which makes this a 2. That cannot be 1. So this become the only place for 1 in row 1 is here. So this is 1. This is a 4 because of normal row Sudoku. This is a 2. We've eliminated 7s here. This has to be 9. So this can't be 9 here. This can't be 3 or 3. So this becomes 2, 3, and 5. So this can't be 2. This can't be 2. This has to be the 2. So this can't be 2. This can't be 1 or 4. This can't be 1. No 1, 7, 9. No 7, 9 anywhere here. This can't be 4 because of that 4. There's no 2 here because of these 2s. There cannot be 4. This can't be 4. This can't be 2. This can't be 4. This has to be the 2 because there's only one space in row 9 for the 2. And that's there. So that's 2. So this only sees 2. And so it's either this one or this one. This is also a border because we have 2 borders. So now how many borders do we have? 1, 2, 3, 4, 5. So this is either 6 or 8. So this cannot be 3. Therefore, there can only be a 3 here. So this can't be 3. This sees, it could see 5, it could see 7, it could see 8, it could see 9. So we know whatever this is. Let's just make, okay, so then this is a 9, which means this is 5, 7, and 8. So this can't be 9. The 9's eliminated from all of these, therefore this has to be a 9. So this can't be 9, which means this is 5, 7, 5, 7 pair, so this has to be a 9 because 5 and 7 are eliminated. That makes this a 7 because it's a regular row Sudoku. This has to be a 9 because of row column Sudoku. This can't be a 7. This can't be 9. We have 3, 4, 5, 6, 7. That's fine. 3, 5. This is 5, 7, 5, 7. This sees, this cannot be 7 because this is blocked by that. So this has to be 5. So we know that's 5. This is 7. This has to be 3 then. This is 5. No 3 or 5. No 5. This can't be 7. No 7. These can't be 5. So this one, let's make this green for now. We don't know what it's going to be. It could actually be yellow too, but this one is either 5 this way or it's 5 this way. So these are all green, and then it sees either that or that. We don't know which. This sees 5, 7, or 8. Okay. We don't know. This is 5. Okay, so it could be 5 that way. It could be 5 this way. So these are the same color. I guess we'll make this red. Yeah. These 3 are the same, and it could extend that way. It could extend even more that way. This is different. So this sees 5. It has to be either here or here. Oh. Okay, so this would be 1, 2. It could be 3, but it cannot be here. This is 4. So 1, 2. It could be here, so that would be 3. Cannot be here. 4, 5, 6. So this has to be 6. It cannot be 8, essentially. So this is 6, which means this can't be 6. So this has to be 8. So we know we have 1, 2, 3, 4, 5. So there needs to be another one. So the only one that could be there is here. So this is 6. Oh yeah, and that already disqualified 9. So therefore this is part of the green. This can never be 1. Right, because it would only be part of the region with itself. So this has to be the 1. This becomes, it cannot be 5, 8, 7, 9. It can't be 1, 2, 3. This is 4 or 6. It can't be 6. So this is 4. This is 7. This is 8. This is 7. This is 4. No 4 or 7 here. So this can't be 4 anymore. This is 3, 5, 6. The green could be part of this yellow, so we don't know. We have a 2. We have this one cannot be part of green. Can it ever reach this 2? If it goes that way, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we have 4 squares which are by itself. So this can never be a part of it. So therefore this is the green. 1. Where are the 1s possibly? So the 1s, we have 1, 2, 3, 4, 5, 6, 7, 8. So this has to be, this is the only space left for the 1. So one of these is green, the other one is not. This can never see that because it's only two. So it's either this way or this way, and then it turns. So it cannot be that way because then that would block. So whatever this is the same. This has 1, 2, 3. So this can never be. We have 3 more, right? This can never be red. It cannot be yellow either. It can't be green. So this is something else completely, right? So this can never touch any of the purple. So we're going to make this purple. So this one specifically is purple. So it cannot be part of the red, cannot be part of the yellow. The yellow could be part of the red. The yellow could also be part of the green. We don't know. The purple. The purple can only get at most 5 this way. Because these are all red and this is yellow. So therefore this has to go that way. This has to go this way. So since this is 8, 9, it cannot be part of green. This is purple separate. So this is at least 3. And it must continue on somewhere from here. So this has to be 6. So we know this is 6, this is 3, this is 4. So this becomes no 3 here, no 6, no 6 here. This is a 7, 8, 9, 7, 8, 9 triplet, so this has to be 5. This has to be 3 then, because it's Sudoku. So this can't be 3, this can't be 5. We have 7, 8, 9, 7, 8, 9, 8, 9 in this row triplet, so this has to be a 6. This is a 5, this is a 6, this is a 5. This cannot be 6. So this has to be a 3 here, which means that leaves the 6 here. So this cannot be 6. This has to be the green 6 because this needs a 6. We need a 1 and we need a 3. So the 3 is either of those. The 1 is either of those. So one of these is green. One of these is purple. We don't know which. This must see 6. This has to see 7 at least. So then it sees it's either this 7 or it's this 7. So these are both red. So that means we know this is a border. So this can't, either one of these is 1. So we see 4 already. So it's either here or here. So we don't know. This could be... Okay, so this one either connects this one. So this yellow, this is either green or red. We don't know which. This is either, okay. This cannot, oh, that could be green or that could be green also. So this is green, red, or purple. Oh, wait, no, this is 7. So if this is, it could be that way. It could be this way. Yeah. So this is green, red, or purple. That's possible. Where is this 2? This 2 has to be with the red. Because the purple already has the red, the 2 here. The green has a 2, so this has to be red. Therefore, this must connect this way. It cannot go this way. Because then that would see 2. So this one has to be red. So this green is red here. Stop! There we go. That has to be red. So there cannot be another red 3. So these cannot be red. So this can't be purple, so this is the green. This can't be green, so this is purple. And it must connect this way then, so this is the purple 1. So this can't be 1. So we have all the greens, so this is done. This has to be separate. So these must connect with the purple. And this has to be 6, so this has to be purple. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it cannot see more than that, this has to be the 2 reds. Therefore, this is 7 and 9. Therefore, that can't be 9. This has to be 8. This has to be 9. This sees 1, 2, 3, 4, 5, 6, 7, 8. Therefore, this is 8. This is 7, 9, 7, 9, 7, and 8. And that's the solution. Yeah, pretty straightforward. Average difficulty seems about average. It takes me a while just to explain things, but yeah, I mean, seems pretty straightforward. I like it. I like these logic puzzles that, you know, you go through these things and that eliminates possibilities. Um, yeah. I guess we can make this yellow because it touches a edge, a corner of the purple. And we have to have different colors. Or at least I do. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care. Oops.